Hi everyone. Welcome to Decoding Kotlin for Unity developers. My name is James Ashley, and the goal of this course is to get Unity developers up to speed on native Android development using Kotlin, the language at the heart of Android Studio and the Jetpack ecosystem. The target audience for this course is Unity developers who want to understand what native Android development looks like, how Kotlin compares to C#, and how to read and navigate real Android code confidently. Whether you're coming from game development, enterprise apps, or other types of work, the Unity and C# experience you already have is exactly the right foundation. The approach of this course is to treat you like professionals who already know a lot. You don't need to be introduced to Kotlin as if you're just starting out as programmers, especially when so much of what you already know from Unity development transfers directly to Kotlin and Android. By the end of this course, the goal is simple. You will be able to open Android Studio, read through real Kotlin and Jetpack code, understand what it does, and start making meaningful changes to it. That is the finish line. Not fluency from day one, but genuine productive competence inside Android Studio. So I originally created a version of this 1-hour course a few years ago. It was called Decoding Swift for Unity developers, and a lot has changed since then, including the dramatic changes that AI has caused in the world of software development, which has been going on since around February of this year. To the extent that we define knowing a language as knowing how to get things done in a language, AI pretty much gives you that ability, that knowledge, for the price of a monthly subscription. With a good LLM, you can very rapidly get an application up and running with very little prior knowledge of Kotlin or Android Studio. So that's one argument against taking this course. But at the same time, having some basic knowledge to get you around Android Studio and to help you read the Kotlin that your LLM is writing for you will make you much more effective. And the combination of a good foundation in Kotlin along with your competence with using LLMs is the winning strategy, I think. And that's the kind of success I want to set you up for. So who am I and what qualifies me to talk to you about this? I spent several years leading teams of Unity and C# developers, primarily for enterprise and retail clients. When client projects started requiring native development on alternative platforms, most of my developers were Unity and C# developers who had never seriously touched another language. So I'm familiar with the difficulties, but also the joys of getting a team up and running with native development. Kotlin, the primary language for native Android development, can look strange and off-putting to C# developers at first, but there are similarities. There are also differences that can make you feel like you're reading a foreign language. So here's what you're about to discover. Many C# programming concepts have simple language analogs in Kotlin. All you have to do is decode those analogous terms and concepts from one language into the other. And at the same time, some Kotlin and Jetpack concepts are genuinely different from Unity and C# way of doing things. And these you'll just have to learn from scratch, but I'll be pointing out those instances to you with a big flashing warning. And once you get over these two hurdles, everything will click much faster than you'd expect. And the shortcut to learning a new language is exactly what this course is designed to give you. Let's recap the 5 learning goals for this course. 1, you will learn the trade-offs between native Android development and Unity development and understanding when each approach is the right tool for the job. 2, you will leverage your existing Unity and C# knowledge to shortcut your acquisition of fundamental Kotlin and Android development skills. 3, you will become comfortable enough with the Kotlin language to read and write code confidently inside Android Studio. 4, you will have a sufficient command of Jetpack Compose to read through source code and understand what it does. And finally, 5, you will read through real sample Android code and be able to answer progressively more difficult technical questions about what the code does. So thank you for joining me on this journey. In the next section, we'll go through the different tools used to develop in Android Studio and how they compare to your Unity development tools. In this section, I'm going to compare the Android development toolchain with the Unity toolchain side by side. You'll need a reasonably powerful development machine and a Google account. And if you decide to develop in Unity, you'll also need some sort of Unity license. So in this section, I'm going to explain the Android dev tools to people who are already fluent in how Unity works. Have you ever seen a bilingual book that has the text in the original language on one page and then has it translate into your native language on the facing page? So I'm going to explain Android DevTools to you in a similar manner, with Android ease on the one side and your native Unity ease on the other. Unity development typically requires two main tools: the Unity editor for manipulating scenes and organizing files, and Visual Studio for writing code. Native Android development similarly centers on two tools: Android Studio, which handles both code editing and project file organization, and the Android emulator, which is your device simulator. In the Unity world, Unity Editor is your home. You open Unity Editor first, then open Visual Studio from within it. You configure, preview, and build your projects from the Unity Editor. In Android world, Android Studio is your home. You start new projects in Android Studio. You write code, configure, preview, and build all from within Android Studio. Unlike the Unity Visual Studio pairing, Android Studio does it all. There is no separate scene editor you launch from it. Scene composition is done in code using Jetpack Compose. Another difference is that in Unity you can run your app inside the Unity editor, but in Android development you run it in the Android emulator. You can also deploy directly to a physical Android device using ADB, the Android Debug Bridge. To sum up, in Unity development, you use the Unity editor and Visual Studio to build projects. In Android development, Android Studio plays both roles. It's your IDE, your project configurator, your build tool, and your launchpad for the emulator or device. The core concept in Unity is the game object and mono behaviors. To build a Unity app, you start with a fresh scene, you add game objects, and you give them behaviors by attaching mono behavior components. To make a game object actually do something, we add a component to it. For instance, a rigid body component that gives our sphere a sense of gravity. When we attach the component and hit play, the ball falls. In native Android development, the architecture you'll encounter when working with 3D content is also built around the Entity Component System, ECS for short. Entities are the objects in your scene. Components attach data and behavior to those entities, and systems process entities that have specific components. You work with session objects, entities, and components, much as you would in Unity's dots, or in a pure ECS engine, such as Swift has. You'll go deeper on this in the Jetpack Compose section, but for now, just know the pattern will eventually feel familiar. In Unity, a scene is a file you create and save in the editor, a container for your game objects and their configurations. You switch between scenes using the Scene Manager. In native Android development using Jetpack Compose, there is no visual scene file. Instead, your UI is defined in code using composable functions. Think of it as a scene assembled at runtime for the component tree that you write. Navigation between scenes is handled by a navigation graph, not a scene file. This is one of the bigger mental shifts when coming from Unity, but if you think of composable functions as your screen's blueprint, the concept clicks fairly quickly. In Unity, you build your project from the build settings window, and Unity packages it into an APK or AAB for you automatically. In Android Studio, your build system is Gradle. It's a script-driven build tool configured through text files called build.gradle or build.gradle.kts. Builds produce an APK or AAB in the same way. You deploy it to the Android emulator or to a physical device via ADB. The learning curve for Gradle is real, but the good news is that for most projects, the default configuration works fine, and you won't need to touch it until you start adding dependencies, which in Android land you do by adding lines to your build.gradle file, rather than by dragging assets into a project window, as you might do in Unity. In this section, we're going to start going deep on Kotlin. We'll work through interfaces and extension functions, two concepts that will feel very familiar to C# developers, and then we'll use that knowledge to understand how these patterns show up throughout the Android SDK. These you will find easy to grasp because they are essentially translations of C# concepts you already know: interfaces, methods, and extension methods. In C# we use both interfaces and base classes to implement object-oriented programming. Good news, Kotlin uses the same word, interface. The concept is virtually identical. Where things do differ slightly is in how Kotlin handles default implementations and interfaces. Kotlin allows interfaces to have default method bodies, which C# has supported since C# 8.0. So if you're on a modern C# version, this will feel very familiar. I'm going to do some live coding now. First, I'm going to open up a C# console project and write some classic interface examples as a refresher. Then, I'm going to open up Android Studio and write the same code in Kotlin, side by side, so you can see how similar they really are. Start with an iAnimal interface in C#. I provide two properties, name and sound, and then I implement iAnimal as a dog class and a cat class, each providing their actual values. Note that in iAnimal I've implemented a default method called greet. In my main class, I instantiate a new cat, call a method on it, and we run the app. You'll notice that the cat goes meow, dog goes woof. Let's run this. I'm opening up Android Studio. And now in Kotlin, I write the exact same thing that I just wrote in C#. The Kotlin interface keyword is identical to C#'s. The class implements the interface using a colon, just like C#. And then you'll notice that we're using an override keyword. Watch how similar this all looks. If you squint, these two programs look almost like twins. The differences are mostly cosmetic. Kotlin doesn't need access modifiers like public by default, since everything is public unless you say otherwise. And property declarations look slightly different, but the logic is identical. And when we run it, the output is pretty much the same, as you would expect. Before we get to extension functions, let's note a few things about regular functions in Kotlin. In C#, you declare a method by writing its return type first, and then the method name. Note how we wrote the greet function. In Kotlin, you use the fun keyword, and the return type drifts to the right after the parameter list, separated by a colon. If a function returns nothing, you can omit the return type entirely, or you can write unit, which is Kotlin's equivalent of void. Notice that in Kotlin, type declarations drift to the right in general. Variable declarations work the same way. Instead of string name equals dog, you write val name colon string equals dog. And once you internalize this type goes on the right, a lot of Kotlin syntax clicks into place. Now I want to refactor. My cat goes meow output is useful enough that I want to share it across types. But let's say I can't change the interface for architectural reasons. In C#, I'd use an extension method for this, called vocalize. And then the next one is going to be specific to cat, and the cat's going to meow, and the meow is going to call vocalize. I just need to change the type from iAnimal to cat so that I can actually call meow. And let's run it. Success. Now here's the Kotlin extension function. I write the type I want to extend, then a dot, then the function name. Inside the function, I can refer to the receiver object using the keyword this, or just leave it out entirely because inside an extension function, this is implicit. And this is actually cleaner than the C# version. Let's also refactor it to return a string instead of printing directly. The refactor looks like this in both languages. When we run it, we get very similar results to what we saw in C#. Now that we understand extension functions, let's see where the pattern shows up in practice. The Android SDK and the libraries you'll use on top of it frequently add functionality to existing types using extension functions rather than cramming everything into a base class. You'll encounter this pattern constantly when reading SDK code. A function that appears to belong to a class may actually be an extension function defined elsewhere, in a library, a helper file, or a Kotlin utilities package. Once you recognize the syntax, you'll know exactly what you're looking at. This is a very idiomatic Kotlin pattern. The Android ecosystem leans into it heavily, which is why extension functions are worth understanding early. When you get to the later sections in Jetpack Compose and Android SDKs, you'll see this pattern everywhere. In the last section, we covered interfaces and extension functions, the parts of Kotlin that feel most like C#. In this section, we're going to go deeper and cover some areas where Kotlin does things a little differently. Its type system, null safety, and control flow expressions. Some of this will feel familiar. Some of it will feel like a small upgrade on what you already know. Either way, these are the language features you'll run into constantly when reading real Android code in Android Studio, so it's worth spending some time on them now. In C#, you can declare a variable with an explicit type, or you can use a var keyword and let the compiler infer the type for you. And then remember, we also have a read-only keyword that you can use, which means that your variable is only going to be read and never changes. Now, Kotlin works the same way. You can write val and alternatively, you can write var. So the compiler is very good at type inference in Kotlin, and you'll often find yourself omitting explicit types unless you need to be clear for the reader's benefit. Now, one thing to note, in Kotlin, val is for values that won't ever be reassigned, like C#'s read-only fields. Var, on the other hand, is for variables that can be reassigned. In practice, you should default to val and only use var when you specifically need to reassign. Next, let's talk about null safety. This is one of Kotlin's celebrated features and one that C# developers will find familiar. So in C#, we do null safety and nullable classes by basically adding a question mark after the class name. And then whenever we use that instance of the class, we have to add question marks also. So in C#, any reference type can be null by default, and you've probably written code that crashed with a null reference exception. C# added nullable reference types as an opt-in feature in C# 8.0. In Kotlin, null safety is built into the type system and is enforced by the compiler. A regular string cannot be null, for instance, but if you want a variable that can hold null, you have to explicitly say so by adding a question mark. And the same thing happens with classes. So if we want to make the cat nullable, we add a question mark after it. And then just like in C#, we have to, with the instance lowercase c cat, also add a question mark. And what happens now is if cat is null, then you just don't get the field or property or method after it to get called. So here we're running it, and you can see the results. The null gets null. So what do we do if we don't actually want the word null in there? We want to put in our own sort of behavior in case we get a null class or a null instance. So in C#, we would do question mark, and that's our null coalescing operator. And in Kotlin, we do something called the Elvis operator, which is a question mark colon. So in C#, question mark, in Kotlin, question mark colon. And now we can say if cat happens to be null and there is no name, then return the string nothing instead, or the string silent. We're going to go through and show you what happens if you're calling a method also. I'm calling the Schrodinger's cat because we're trying to evaluate what happens when there is no cat. And you can see we've been able to replace the default null. And that question mark colon is called the Elvis operator in Kotlin because it sort of looks like Elvis sort of turned on his side. Safe call operator, which is question mark dot dot. But if you ever need to assert that something is definitely not null, and this is very risky, you can use the exclamation mark operator, which is Kotlin's equivalent of saying, I know this isn't null, but just trust me. And if you're wrong about this, you get a null pointer exception. So what I want to show here is if I take out the save call operator, the app actually won't compile. So let's say this is a problem, and we want to see how we get around this. See, even if it's a cat there, since our class is nullable, type safety stuff says don't do this. So to make our application compile and basically force it to, we put in the double exclamation mark, and now it compiles. So the next thing we want to look at is in C#, we have a switch statement, which lets us branch on a value. Now Kotlin has an equivalent thing called the when statement. So in C# it's switch, and in Kotlin it's when, and significantly more powerful. But first, let's go ahead and modify our code using a switch statement. And the way we're going to do this is we're going to choose what animal we're actually going to instantiate based on input from the user. So we do a read line, let the user add something, and then we do a switch statement. And if the user said dog, we're going to make our animal instance of type dog. And if the user put in cat, we're going to make our animal instance of type cat. So pretty simple switch statement and a little bit contrived, but and of course, remember always, if you're doing a switch statement, have a default fall through. Okay. So now we've done instantiation. We're going to simplify our output a little bit. And instead of always writing dog, we're going to write whatever the animal is. And of course, since it's nullable, we'll go ahead and use our null safety operator, run the whole thing. Okay, so now let's do the same thing on the Kotlin side, and we're going to replicate this basic same code using the when statement. We'll grab the input from the user. We're going to create an animal instance, set to null initially. And we're going to do the when on the input. I wrote something wrong there. Oh, I know. That's a C# predicate operator. We don't want that. We actually just want a dash and a greater than. Okay. And in C#, we use a colon. In Kotlin, we use dash greater than. And in C#, we use the default fall through. And in Kotlin, we use else. What did I do wrong? Oh, right. It's not parentheses, it's squigglies. Okay. And now let's modify our output also. And pretty much what I'm showing here is that the when statement with a little syntactic difference is going to be the same as the switch statement. And let's run it. So good news, we get the same results as we did in C#. So next I want to go ahead and show you the smart cast with the is keyword. And we're going to work up to something. But basically the is keyword in Kotlin is equivalent to C#'s is operator for type checking. And just like C#7's pattern matching, after an is check succeeds, Kotlin automatically smart casts that variable to the match type. So you don't need to cast it yourself. Pretty handy. So basically, when I do this check if animal is cat, if it goes through, whenever I call the animal, it's already being cast as a cat. So first of all, I know it can't be null. It really is a cat. So I can use that bang bang operator. And I'm totally safe in doing this. Maybe this is one of the few cases in Kotlin code where I am perfectly safe to do this. But here's the interesting thing. Because it's a cat, even though the variable is animal and is originally cast as the animal type, I can still call meow in it. You're never going to see that in C#, I think. So we're going to go ahead and run it, but obviously the cool thing is not only does it compile, but even the IDE recognizes that this is legitimate syntax, like magic. And the results are here. Calling it animal meow actually works and gives us this result, the cat goes meow. Now, we're not going to cover it, but I just wanted to add that what makes Kotlin's when statement really useful is that it can match on much more than just values. You can match on types, ranges, conditions, or even the result of a function call. And in Android code, you're going to pretty frequently see when used to handle different result types or event states. But the next thing we're actually going to do is talk about how to use the if statement. So one thing that trips up C# developers at first in Kotlin is if is an expression, not just a statement. And this means that you can use if inline to produce a value, which is pretty much the same way you'd use the ternary operator, question mark, and then a colon in C#. And we're setting this up by first instantiating a message, and then we're going to print out my pet likes whatever that message is. And then to evaluate that message or to assign it, we're going to check what the animal is. And again, in C#, we'd use a ternary operator like this, the question mark colon, but that doesn't work in Kotlin. But that's very easy to fix. We're going to use an if statement instead. So if my animal is a dog, and instead of the colon, we're going to use else. So my dog likes dog treats and my cat likes $100. We run this code and my dog likes dog treats. Yay. Okay, the $100 bills thing is a little bit weird, but I'm thinking ahead because I want to show you the next cool thing, which is the multi-dollar sign. Really weird. I almost didn't want to show this, but you're going to run into it and wonder what it is, so we need to cover it. And the basic idea is this is how you do complex string templating. So in C#, when we do, if we want to have a string that includes actual variables or something, we put a $sign at the beginning of the entire string statement. That's not how it works in Kotlin. In Kotlin, we put the $sign right before the variable that we're going to use inside of this string statement. But what happens if you actually want to use a $sign in there? Then it gets confusing, right? Because we have this particular syntax. So by default, if you have too many $signs, one of them is just treated as a literal. And what this means is I'm just writing the full syntax. You basically have one $sign before your whole statement the whole time. And what that says is $1 is always going to be this sort of literal escape thing. But I can change that so that my syntax now says $2 means a literal escape. And therefore, if I have $3, one of them is treated as a literal. And I get my pet likes $100 bills again with the $sign in front of it. So now if I want to get rid of that $sign in front of it, I just have the double $sign, and double $sign signifies escape. Okay, so it may seem like I belabored that point, but basically this weird multi-$sign feature, since it's already in there, it just has to be explained because you're going to start seeing it in code that you read. Anyways, let's go ahead and move on to the next section, Kotlin collections and coroutines. In this section, we're going to start over with the basic animal code, and we're going to try to show some really advanced features that you can do in C# and then show the Kotlin equivalents. The point of doing this is not to teach you every specific Kotlin language variant, but just to let you know that it's possible. So my thinking about it is that when you're in C#, you have certain tools that you just reach for when you're ready to do it, things like lambdas and coroutines. And it's important to know when you're playing around with Kotlin, getting to know it, that those things are also there. So you don't have to know the specifics. You just get to know that it's available to you. When you reach for that tool chest, switching from C# to Kotlin, those tools are still going to be there. Okay, so the first thing we're going to do is go into animal, and in order to support this more complex project, we're going to add some extra properties to our iAnimal. Let's see. So autocomplete is a great feature in Visual Studio. And basically what I'm doing is I'm adding 3 new properties: pet name, age, months, availability, on top of the stuff we already have, the animal type name and the sound that it makes. And the notion is we're going to create some sort of pet adoption agency. And we're going to have a repository with data. We're going to mock up some sample data, really make it complex. And here I'm just adding some initialization methods. So we want to have somewhere we pass in our fields, and then default ones also. Okay, this is looking right. Yep. Continuing on, I'm going to write a config class, which lets us know what sort of animals we're going to have available, some conditions on that. We also want to write up some methods to get our mock data. And since we can do this in C#, we'll even make those calls asynchronous. So we use the async keyword and make sure our return type is a task. And now we're just going to fill in some sample data. Unfortunately, we've got those initialization methods that we created. Makes creating sample data much easier. We're going to have one list of just the regular animals that are already there. And like a lot of pet adoption agencies, also some new ones that just arrived. And each animal has an animal that, a name that we've given it, and then age and number of months. And then we specify whether the animal is actually up for adoption or not. Okay, and now we're going to write our repository class. And that's going to give us methods to pull on the objects that we need. So eventually we'll go back to that main method and start calling our available data and so on. But here we're creating view model, and the idea is that eventually we can turn our console app into a Unity app, and this is a mono behavior class. So we'll create a view model that connects all of this together. And the view model instantiates a config file, says we have minimum age for animals that are adoptable. We want to make sure that they're available, otherwise we don't want to let people adopt them. And we're doing this async refresh method where we get all of our residents, we get the new arrivals, we combine them together with our concat method. And here's the fun part. So we have all these beautiful link methods, and I'm putting them here to show them off, but also to remind you that these are the kind of tools that you're also going to have in Kotlin. So it's called sugar or syntactic sugar. Just really nice ways that you can do something you can do otherwise, but this makes it very condensed, elegant. And you can see we're doing a filter on all the animals we're pulling in. Then we're ordering it. Then we specify how the output is written, and we turn the whole thing into a list. I'm just writing some methods here that we're going to use later on. What's wrong with this? Oh, it's nullable. So we're going to add a question mark. So that's a nullable string. Gets rid of the errors. Okay, back to main. We're going to make our main method async, make it return task, and that'll allow our console app to call async methods. So I need a read-only repository to pull my data. Okay, and this is our magic view model class that we can later kind of combine in Unity. And now let's adjust what we're going to call. We're going to do an async call to our view model VM and call the refresh async method. And that's doing all the concatenation of the new animals and the old animals, applying filters and order and our beautiful link methods. So we're going to take the data that's returned to us, we're going to join it with this literal new line. And that just adds an escape character after every line. And now we're going to output it into our console. And then the scary moment, trying to run the whole thing and see if it works the way I was hoping it would. Yep, so we're calling refresh async. It pulls in these repository methods, then it sorts and filters on it. The moment we've been waiting for. And yeah, our pet store returns our animals that are available in a nice form that tells us how old they are, and then pulls in some of our old code about vocalization. Fabulous. Now on the Kotlin side, I want to start off by adding properties to our interfaces and classes over there. And for the most part, it's done exactly the same way. Okay. I'm taking a lot of shortcuts using the IDE to help me finish this out. Now we're going to redo the main call. So let's start adding our extra stuff. And this is going to be the most basic implementation. And we're not going to use all the super features yet, but just try to implement the same output. So we're going to create our config class, our view model. And this is where in C# we use a lot of link, and we're just going to use bare bones sorting in order to accomplish the same things over here. And this is going to create our starting point. And again, I want to reiterate, the point of this isn't so that you learn every small Kotlin feature. It's just that you can watch this and know that what you did in C#, you can also do in Kotlin. And obviously, you've got a lot of help with this now. You've got the IDE, which will make suggestions on how to write your syntax. If you want to, you can use an LLM to go ahead and give you guidance or even write the code for you. So not a big deal. Here we're creating a repository so that we can pull up sample data. And finally, our main method, again, we're instantiating that VM, calling the refresh method, and then printing everything out in a nice form. Great, we run it, and yeah, and you can see it looks a lot like what we had in C#. So mission accomplished so far. So the next thing I want to tackle is all of those nice link features that we have in C#. I'm going to start off by taking our mutable list and making it immutable. We don't need it to be mutable anymore because we're going to be creating it in a different way. So shelter config, I'm also going to rewrite a little. I want to use a particular syntax, an apply call that allows you to instantiate the object and also return it. There we go. So, okay, and now we're going to do some major changes. We're introducing all those cool link calls, but on the Kotlin side. The first thing we're going to do is assign to the adoptable variable that we had created previously. And we're getting residence passed to us, so we're going to call a filter on it. And a filter is the Kotlin equivalent of the where predicate in C#. And so we're actually using some interesting syntax here. Instead of doing a predicate x big arrow x dot available, we have this special syntax it. So instead of x arrow x dot, we can just do it dot. So we filter where it is available and where it age months is greater than or equal to the min age months. Okay. And then ordered by descending in Kotlin is sorted by descending. And then also in map are special things that we've got over here in Kotlin that I don't think we have in C#. Also lets you just add some extra things to what you're working on. And then map, well, I guess map is a little bit like select. It basically says, here's what you pull out and put into the array that we're going to return. So map replaces both select and toList. Okay, and let's run it, see what we get. Awesome. So that's a syntactic sugar on the Kotlin side. Now the last thing we want to do is go ahead and demonstrate doing async calls, right? Or coroutines. And I'll just make an admission up front now. You can't totally do it in console app in Kotlin. You have to actually do some sort of UI, but we're going to come as close as we can. So the first thing is creating our shelter repository where we mock up our dummy data. And we create these two calls, just like we have on the C# side, one to fetch the residents of our pet shelter and one to fetch new arrivals. And now in our view models, we're going to instantiate this lazy instance of shelter repository, which is awesome. It basically says we're going to wait till the last moment to instantiate repository after we instantiate shelter view model. So just a different syntax to do the equivalent of our lazy calls in C#. Okay, so now we're going to do our two calls. We're going to instantiate a value. which means it doesn't change. We're going to call it all, similar to what we did in C#, and concatenate together our residents and our new arrivals. And refresh doesn't take anything, and we call awesome. So we called two different methods. Then we applied all of our link style syntax on top of it to filter and order by and so on. So now you should understand the Kotlin equivalents to what in C# we have. The lambda, our collection manipulation, link syntax, and the basics of doing async calls. The goal of this course was to help you become comfortable working in Android Studio, reading and understanding Kotlin and Jetpack Compose well enough to open a real project, read through it, understand what it does, and start making changes. Not fluency from day one, but genuine competence. My hope is that you've achieved that. You can read Kotlin, you understand how Jetpack Compose UI is structured, you know what a view model is, how coroutines work, and why nullability matters. That is a real foundation, and it opens up a lot of doors. The best thing you can do right now is open up a real Android project and read it. Not build it, just read it. Pick something from the official samples and try to trace the flow. Where does the app start? How does it pass data around? And where does the UI get built? Google maintains a set of sample apps specifically designed to show Jetpack Compose in practice. These are well-written, well-structured code bases. You won't understand everything immediately, and that's fine. The goal is to read them the way you'd read a code base that you had just joined, looking for patterns, recognizing things you know, asking questions about things that you don't know. Find a feature that interests you and make a small modification. Change a color, add a text field, swap out a navigation destination. The act of modifying working code and seeing what breaks and what doesn't is one of the most effective ways to consolidate what you have learned. Kotlin is a broad language, and this course covered the parts most immediately relevant to Android development, but there's more there when you're ready for it. Kotlin flows are the reactive counterpart to coroutines, and they let you model streams of data over time. They're central to how modern Android apps handle live data from networks, databases, and sensors. If you've understood the coroutines section in this course, flows are a natural next step. Kotlin multi-platform is worth knowing also, even if you don't use it immediately. It allows you to share business logic across Android, iOS, and desktop apps, and it's becoming increasingly relevant in cross-platform teams. Your Kotlin knowledge transfers directly. When I came to Android development, I came to it from the Unity and C# world, exactly like you. And the thing that made the biggest difference was realizing how much of what I already knew transferred directly. The component-based architecture, understanding of how projects are structured and built, the programming instincts built up over years of writing C#. What I had to learn was the new vocabulary. Kotlin instead of C#, Jetpack Compose instead of Unity UI Toolkit, Gradle instead of Unity's build pipeline, Android Studio instead of the Unity editor. Once I rebuilt my mental map with that vocabulary, the platform started feeling very familiar. And that's exactly what this course was designed to give you. Wherever Android development takes you, mobile apps, enterprise tools, games, or platforms that we haven't covered yet, you now have the foundation to get there. Thank you, and good luck on your Android journey. Oh, that's it.
But I know that you also wanted to share some cheat sheet.
Yeah. So obviously in a 1 hour course, you're not going to remember all of that. So it's all written down here and tries to give you an easy way of remembering the translations for going between C# and Kotlin. And again, when you see it right in front of you, it becomes clearer how much they really match up pretty well. And I've dropped that in the chat channel. Yeah. Does anybody have any questions? We have just a little bit of time. We've got 3 minutes, right?
Yeah, I think people are coming slowly here. I don't see any under the Q&A, but if you have questions.
Anyways, so I hope that was also a good segue for all of you who are going to watch the Pico course next. So now you've got the foundations of the language, and then you can see what they're doing with it, which is pretty exciting.
We got a question. Whether there is any learning resource for UI composition 3D objects.
Yeah, so that's the Jetpack Compose. We didn't get a chance to put that in, and it's complicated, and it's not the same way that Pico does it. So just to make this series of courses make sense, we've left that out so that Pico can explain to you how they do the UI.
Yeah, the purpose was that after this, then you can just choose which platform you want, and then you can just start building. Either it's a Pico or Venerate or whatever
Right.
Kotlin
Or the
based.
Android SDK. Yeah. Mhm. Well, thanks everyone for spending an hour with me. I really appreciate your time.
Perfect, James. Thank you for all of these things. We have a few more minutes. Pico team is also coming by now. So, but I have a question.
Mhm.
So, right now there is a chance that people can a little bit more understanding native, right? So what is the maybe one, two tips that you can share, like not only from a language side, but since you have built for Walmart and all the top companies on native, what are the things that they have to be careful while they are building compared to a Unity pathway, like that they have never seen before? Anything you would
Uh,
like to say?
yeah, probably the big thing is from what I'm seeing, Android is doing glasses, Pico is doing glasses. So we're not looking at trying to build full 3D worlds anymore, right? Um, and all this information is slowly coming out. But as far as I can tell, because we're concentrating on glasses, it has more to do with panels that sit in front of you instead of full 3D spaces. It's partial 3D, but not the full thing, right?
Mhm.
And for me, that's a big mind shift because I'm used to thinking about AR and VR apps in that way as being alternative worlds that you slip into. So a lot of what you're going to build is going to look different. On the other hand, hopefully that also means it's easier to develop. If for the most part you're developing interactive panels that sit in front of your eyes.
Yeah, perfect, perfect. One more question, maybe. For the native side, right now, um, there are a lot of agentic stuff going on, right?
Mm-hmm.
So maybe since we will also go to the a little bit MCP and some agentic stuff, Matt and David will a little bit mention about that. But I would like to hear like for an since we become a little bit of native builder now, how you are imagining that this agentic uh, collaboration with
Yeah,
native building will work compared to Unity? Is it easier? Is it a little bit more difficult? Just to understand like how you are imagining agents or Fable go hand in hand while you are building an XR experience. So how you are
it's
imagining
it's
that?
absolutely amazing.
Yeah.
I mean, for the most part, it, all the LLMs have some trouble figuring out 3D spaces, which
Hmm.
again, since especially with the Pico and the Android glasses, you're not really doing full 3D, you're doing panels. It's probably even better with that. And for the
Hmm.
most part, the agents can write whatever you need. So that if you're working with agents, the problem for you is first, can you envision what you want the app to do, right? You
Hmm.
don't want to say just, well, I mean, you can just say, something weird like create me a cooking app and it's going to create you something nice. If you have a clear vision of what kind of cooking app you want to develop for your glasses, let's say you're going to build something even better. So then if you're doing agentic coding, it's knowing the syntax is not the most important thing anymore. Instead, the most important thing is having a clear vision of the design that you want and the functionality that you want, right? And then on the back end, you do have to know enough of the language so that you can read through whatever the agent has created for you to make sure that it's kosher. Um, and part of the reason for doing that is just habit too, right? If you're using agents, I've seen a lot of people just sort of forego any sort of testing or evaluation afterwards because it kind of slows you down. But on the other hand, that makes you lazy too. So it's
Yeah.
important to keep in practice with the idea that you need to check the code that the agent is writing, even though 80% of the time it's perfect and better than you can do yourself. And you have to keep in mind that you want to be able to test that design that you envisioned in the first place to make sure it's working correctly. So
So,
that's been my experience with agents so far. Uh,
so for a person just learning Kotlin and native today, starting from
yeah,
today,
yeah.
how I will not make myself lazy and then start continue learning a little bit more, just enough, so I can not only build whatever I want, and I can also use agents with my limited native knowledge. I ask a little
Yeah,
bit complex question, but I
no,
think
no,
this is
I
this
get
is
it.
yeah,
I think that the important thing is you have to discipline yourself a little. Um, and so again, there's this thing called AI poisoning, right? When you
yeah,
start using too much AI, it turns out you actually stop thinking and you
yeah.
don't even realize it and you trust your agent too much. Um, so the important thing is to just discipline yourself. It's like exercising certain brain muscles. Make sure you go back, review the code, make sure that you understand what it's doing. And if there's part of the code that you don't understand, give yourself an hour just to do some research on it. Or, even better, if there's code you don't understand, pull up Claude or pull up Gemini, paste it in there, and have your LLM explain it back to you.
Mhm.
Um, and understanding is just really, really important, I think, at this point.
Perfect, perfect. And you had very nice comparisons side by side. I think this will be really helpful to make it even having a much better perspective on this. Last question, like if I'm using agents for my native development, you a little bit mentioned about that, but just to understand maybe one last point, how it will be different than using agents and MCP for Unity. Like, will I have a different experience with cloud and everything, or will it be a similar thing? Or is there anything different while I'm dancing with an agent while
Mhm.
building with native as a new learner?
So the Unity AI stuff, I think, is absolutely amazing. I get the impression that's going to be expensive and get progressively expensive. So compared to that, if you have a max plan on Claude, I think you're getting more bang for your buck with Claude, maybe. On the other hand, the other nice thing about if you're inside of Unity using their AI tools, there are a lot of hooks in, right? Like
Mm-hmm.
you can go into a texture and call up the AI there and say, change this texture or write me up a texture. Or you go to your models and say, generate me a model that looks like, a troll with a club walking through my scene. And it'll do it. And it's pretty impressive. Whereas if you're using an agent, you're thinking more in terms of words, right?
Mm-hmm.
Um, you have to have a full concept in your head instead of leaning on the IDE to break down, here's where you create materials, here's where you create meshes and so on. Here's where you create monocode. Instead, you actually have to know how to make your code work together. And it seems to me that that's probably the big difference. But
Okay,
again,
okay.
it's kind of too it's what you're used to.
Yeah, because
So
one of them is much more like a game engine, the other is more like a you are directly natively being part of the development journey. So yeah, I could imagine.
mhm.
Perfect, James. Thank you for your time. I think it was very nice